So Clive Bentley, let me welcome you to the RSS Reading Group and the event that we've got this evening to talk about tranquility. And what has impressed me is the statistics that you've put behind the calculation of tranquility, but I think today will be focused more or less on the requirement for tranquil environments and the application of the statistics rather than going into the depths of the statistics themselves. So welcome to the group, and your talk about, I won't say very much because you really need to motor on through it. So okay. I will stop there and welcome, and I hope that everybody enjoyed it. I find it a fascinating subject, and the grip that you've got on actually assessing it and measuring it and so on, remain singularly impressed.
What a nice introduction. Thank you, Jeffrey. Hello, everybody. It's a bit odd not seeing you at all. I never quite get used to these things. I'm Clive Bentley. The plan is, I think, if you have something you wish to ask a question about, just go ahead and ask. Unmute yourself and say hello and talk to me. I'm going to assume that most people here are more interested in the statistics than they are in the subject of tranquility, but I'm also going to assume that you'd like a bit of an overview. Hopefully everybody can see the screen. If not, please yes. Tell me now. So this is a lovely bluebell woods, and the sounds here are purely natural in this picture. Bird song, a little bit of light breeze in the trees, absolutely beautiful. I imagine that's what we mainly think of when we think of tranquil places. I hope so. For some reason or other, I can't get it to go to the next slide. Let's try that. Good. Why is tranquility important? So, question for you all to think about. Why do you think tranquility might be important to you? Is it important to you? I think it is to most people. When you're thinking hard all day, and I'm imagining that statisticians probably do more of that than the average person, you focus the mind, you direct your attention in a particular field, and you focus, and obviously that's very good for the production and so on, but it doesn't. It tends to exhaust your brain a bit, and one looks for a tranquil refuge when one is doing that, in order to restore the balance in your mind. Tranquility is, after all, a mental state, not a place or anything else. It's a state of the mind. So protect tranquility is an important thing. We are losing it in this modern world of ours, and so there are things in place to protect it. Recently, 2012, there was a government planning policy introduced the idea that we should protect it. That's been updated more recently in 2021. So when planning decisions are being made, local authority long-term plans for an area are being considered, and tranquility needs to be part of that now for the first time. Well, for the last 10 years now. The problem is there's not a very good definition of tranquility. That definition there that I put on the screen actually came about shortly after I shared my research with the person that advises the government, and I think largely came from research by myself and one or two others. It's not a very clear definition. You're talking about making a planning decision based on, are you protecting tranquility? How on earth do you decide whether somewhere is tranquil, and if it is, whether it's going to be protected by whatever's being proposed? There's a number of different ways where that people have gone about trying to define what makes somewhere tranquil or not. The CPRE, the Campaign to Protect Rural England, did a lot of research in the 2000s, the noughties, came up with a method based on GIS data. It's pretty good as a campaign tool. It enabled the CPRE to get the government policy to consider it, which was very worthwhile. But it's not very good because it's only a 500 by 500 meter square grid, and it doesn't take account of natural sounds. And it kind of falls down when you actually try to go into any kind of detail. There's the University of Bradford developed a method, which I'll come on to in a minute, which looks quite good and I thought would be workable, but it turns out it doesn't really do quite what it needs to do. So if you're actually going to consider protecting tranquility at the planning stage, or even at the design stage of something that is being proposed, you need a method that works. So this was my aim in starting my research 6 years ago now. We all know what tranquility is. It is difficult to define. There are some definitions that are out there: quality of state of being tranquil, freedom from disturbance and agitation, serenity, calmness, quietness, peacefulness. It's all pretty vague stuff. We all know what it is, but it's very difficult to really pinpoint. Kind of important, again, good one to ask you about if we had a bit more time, is what do you think makes a place tranquil? Probably most of us would say peaceful, quiet, lack of noise. Man-made sound is bad. Natural sound, actually, it turns out, is good. Natural features, some trees in the area, for example. It's what else can you say about tranquility? It makes you calmer. Yes, your mind. So there are things that you can quantify. Things that are, you can say they're there, and you can quantify the degree to which those things are there. And then there are other things which you can't quantify. So somebody might be a depressed person, they might be a happy person, they might be an aggressive person, it might be a temporary situation or a permanent situation, they might be particularly stressed, they might be particularly relaxed. It might be their favorite place that they go every lunchtime, or the favorite place that they went to when they were a child, or there's people have links with the place that are entirely emotional links, and their feelings about it are not affected by what's actually in front of them, but by how they feel about it. And it can even be affected by, if someone's gone on holiday and they've traveled 300 miles to get wherever they've gone, they will automatically feel more positive about it than someone who lives next door. Interestingly, there's research to back all this. If you're interested, you can read the book. So yeah, there's other things like the weather, presence of other people. And it's not just the presence of other people, it's also the behavior of other people as well, because other people on their own can actually be a good thing. For a lot of people, they want to feel a few others around them, at least to have a sense of security. For some people, being completely on their own feels isolation, feels it as a lack of security. So it's not just the presence, it's the behavior of the other people. Are they loud shouting, or are they quiet and peaceful with you? Insects biting, unpleasant smells. There's lots of other things that can influence things. Water's very good, birdsong's very good. Character of the surrounding area has a big influence as well. All of these things are important when you're looking about how tranquil somewhere is. Tranquility is important because it provides soft fascination, unlike hard fascination. Really, really interesting subject, but I can't go into it at the moment. If you want to know more about it, again, you can read my book, or you can look into the research of a chap called Kaplan. Attention restoration theory. Anyway, so somewhere quiet. So what's quiet? There is no definition of what is quiet. You could look at the EU has a sort of definition for its noise mapping, which is that it says a level should be between 30 and 40 decibels. But that's a bit nonsensical, because if you go and sit in my back garden, which is a little suburban back garden, you hear road traffic all over the place, whatever, the birdsong there is about 45 on a normal day. So 40, it's a bit meaningless. And there are places where noise levels are below 30. There are very few places where noise levels are below 30. And then there's no hardly anywhere in cities where it's above or it's below 40. So really just measuring a noise level isn't enough to tell you whether something's noisy or quiet. So we talked about briefly about man-made sound, natural sounds, different characters of sound affect things, and the fact that people will filter out sound as well. Very often you can sit in an urban park and feel very much at peace. If I walked up to you and said to you, can you hear road traffic? And you stopped and thought about it, you say, gosh, yes, I can hear a lot of road traffic. But until I'd asked you, you probably wouldn't have noticed it, because if you filter it out, you get used to it. Anyway. So what did I do? I wanted to find out how to define tranquility. So I went out and started doing some surveys. I did a lot of surveys. It wasn't just me, it was a team. I had probably about 25 people in all help me over the years. Volunteers, other people I worked with that had spare time on their hands, not very much of that, but took measurements, took photographs, panoramic photographs, looked at levels, made observations, questionnaire surveys with people, found out a lot about it. Our original goal was to use the University of Bradford method that we found, which is known as TRAPPED, which is tranquility rating tool or something like that. That's not right, is it? Something like that. And the tranquility rating tool was derived by linear regression from a study that was done by a couple of very clever guys at the University of Bradford. They looked at natural contextual features, NCF, which is the percentage of a panoramic view around a particular location, which has natural and contextual features in it. Natural being trees, woods, nature things. Or contextual could include things like old cottages or castles or something which sort of feels like it's part of a natural environment, even if it is actually man-made. It's a little bit ill-defined, that. And then it takes a 0.041 times NCF, and then it looks at the LAQ, which is basically the average sound level. In the case of TRAPPED, that is just purely noise from road traffic. And then there's another thing which is called moderating factors. So if there's litter or graffiti, they take -1 onto that, or if there's something that's nice like water around, they add 1. That's a pretty crude way of doing it, but they put it into that simple Y equals mx plus c type formula, and come up with a number. And the number is, if it's below 5, it's unacceptable. 5 to 6, just acceptable. 6 to 7, fairly good, and excellent, as you can see. We went and did that. We got 400 locations into it, and this is the graph that we got. So the y-axis on this was what we actually scored the place by saying, well, we think it's good tranquility here. Now let's record the NCF and the other things that are here, and these are the scores we got, with the tranquility x-axis being the actual tranquility score predicted by the method, and y-axis being, so it's pretty bad correlation there, really. So I slowly came to the conclusion that the NCF, the natural contextual features, just didn't correlate at all with our scores or the scores of the members of the public. Don't really quite know why this is, because it's fairly obvious that what something looks like does affect its tranquility. But I think it might be just simply that I think it's a binary thing. Either we feel immediately it is tranquil when we look at something, or we feel it is not tranquil. I don't think there's the scale. There are other possible reasons why, but anyway, we dropped it in the end, dropped the NCF completely, which is a brave thing for me to do. And I came up with some new things which had occurred to me and other surveyors as we went round. We separated out the overall noise level and the level from road and rail, and measured those two things as separate. We then came up with a thing called a PONS and a thing called a NAM, and I'll come into those, what they are, in a minute. I mentioned it there, but I'll come on to this quickly. Road and rail. This is really interesting. We found that all of the other methods that are out there, all of them, all assume that people's response to road traffic noise is a linear response. So the effect that it has on tranquility changes the same between 30 and 40 decibels as what it does between 40 and 50 decibels.
Sorry, Clive, I think there's a question. There's a raised hand. So if you can unmute yourself and ask the question, go ahead.
Sorry, Clive, I just wanted to ask this question so that I can follow you. So in one of the slides there, where you were drawing the correlation, I didn't understand what the individual dots were.
Oh, so each of these is a reading. So, for example, at this site here, can you see where my pointer's pointing?
Yes, I can.
Just pick that one out at random. We felt that particular point there, we thought that had a tranquility score of excellent. That one.
Okay.
So it was an 8. Okay.
Yeah. Okay.
But the actual score, according to this formula here, gave it a 6.1. This one here, we thought it was a score of 6.5. Well, we scored it as fair, and the tranquility score was good.
Okay, so these dots are different places and not different individuals making the score.
There are a range of different individuals doing this.
Okay.
And I will come on to the differences between different individuals a little bit later on. We took from the outset the assumption that if 4 people went to, or 10 people or whatever went to a particular site, we would all probably score it differently. But it turns out we generally agree, you don't get that much variation. It's surprising. We did find 1 or 2 people always underscored or overscored compared to other people. And actually, we had to exclude 2 people from our survey group because one who was brought up on the Isle of Skye just basically thought everywhere was rubbish, and another one just couldn't get his head around the idea that trains made any impact on anything. And there's trains going past, thundering past that annoys us. I'm completely happy with that, he said, and it doesn't bother me at all. So yes, there is variation in individuals.
Thank you.
Does that answer your question?
Yes, that did. Yeah. Thank you.
Okay. So so basically, people's response to road is nonlinear, and it's kind of, that blue line is artificially generated. It's not an exact following of that, but it's roughly like that. That's what we found. So NAMs and ponds, which I mentioned earlier on. So we wanted to separate out natural and man-made sound, and so we created a scale, a 1 to 5 scale, to do that. And we also created alongside that another parameter called ponds, which is percentage of time for which one can only hear natural sound. And within that, if it is completely silent, that classifies as natural sound. So just to give an example, if you were in a park, say, and you're at the sort of quiet end of the park, and most of the time you can't hear man-made sound, but occasionally people walk past and say good morning or play a game, or a dog goes woofing past or whatever like that, you might find that the ponds is 80, whereas you could be at the same level of noise, but it's there all the time, and that would reduce the tranquility. That would reduce the pond score, which would affect the tranquility score. So the application of NAMs and ponds is a little bit complicated, and there are a set of rules about how to go about doing it when road traffic is present, because you kind of have to ignore road traffic up to a certain point, and then it starts to become more important. But I won't go into the boring detail of that. So we assessed NAMs and ponds, I would say sort of semi-subjectively, in that we didn't actually carry a stopwatch for most of the time. We did it roughly by what we felt that it was like. But interestingly, I did also carry out a test where I got people to assess the ponds as they guessed it, and I actually measured the amount of time where there was only natural sound. And actually, there's a very, very good relationship between people's guesswork and what we actually found. So I was quite pleased with that. The NAM, score of 1, all or virtually all sound is from man-made sources. Score of 5, all or virtually all sound is from natural sources. 3 is 50-50, and 2 and 4 are obviously halfway in between there. I have defined that more numerically, but to a layperson, that's a pretty good guide. Again, we tested this in the field, and we found that actually people are pretty good at gauging roughly where things are, and it is fairly repeatable, which is good. So our tranquility scores that we came up with, I slightly changed what came out of the University of Bradford. I didn't like the word acceptable, because it's slightly emotive. So I used not quite tranquil and just tranquil instead. And I also went down into less tranquil areas, and I came up with unsettled and slightly busy and noisy, frantic, chaotic and harsh. It all got a little bit too complicated, so I simplified it a couple of years ago, a year ago. So the tranquility score on the left there, the actual report that we do now, is the column on the right. It seems to work pretty well. So we went out there, did some more using the same 400 locations that you saw earlier on and that you asked the question about. We adopted the NAMs and the ponds. We had to go back and resurvey a lot of places again, and this is what we got this time round. So this time, again, on the y-axis, you've got the surveyor score, and on the x-axis, you've got the predicted score. We've dropped the NCF, we've picked up the LEQ, the NAM, and the ponds, and the LRR as well, actually. And as you can see, that's not too bad. And I was quite pleased with that to start off with. But as statisticians, I suspect there's something screaming at you about this, isn't there? Anybody going to tell me what it is? No? Okay. Residuals are all wrong. At the top end, we've got everything is we're getting excellent results, but we're not quite managing to predict excellent results. At the bottom end, we're getting results that are saying not tranquil. and we're saying might be a little bit tranquil. So we get there's an error in there. I couldn't work out what to do with this because I only knew really properly about linear regression. So I spoke to a friend of a friend, as it were, and who is a statistician, and he pointed out that tranquility scores are nominal rather than ordinal, and also that I shouldn't be using linear regression. I should be using multinomial logistic regression, which is completely new to me. And obviously, I'm not going to try and teach you about that because I would be embarrassed about how little I know about it. But hopefully that makes sense to you. So went out and did it again. Reran everything. This time round, we also looked at what we call demand characteristics, and we tried to take action to make sure that we weren't automatically, I don't just mean myself, but I mean other people that are helping me to do this survey were not giving me the answers they think I want to hear. Had a little bit of training on it for everybody on making sure that we're aware of the importance of reporting things as seen and not as influenced by some other thing. Spoke to Jeffrey for the first time in 2016 and then again in 2019, and he tested what I was doing, asked me some good questions, helped me get some encouragement that I was going in the right direction. A load more survey work, looking at odd situations where you've got very high levels of sound, but they're all from natural sound. I spent a lot of time looking at aircraft and what influence they have, and looked at other things like sound character. For example, if you're next to a child's playground, you get a certain noise level, but because there's screams, that kind of makes it more shrill and more has a bigger detrimental impact on tranquility than a sound that isn't a scream, and things like that. The other thing we did, we pruned out unreliable data. Now that sounds like we're cheating, but I actually threw out a lot of what looked like very good data by doing that. But anywhere where we couldn't be sure that it had been gathered correctly, it had to go. So we got rid of probably, I don't know, maybe a third of the data in total. I don't know, something like that. We realised we couldn't use the public. Almost every member of the public overscores their favourite and familiar places. The only members of the public we could rely on were people who hadn't visited the site before and had no prior association. But we did find that for people that did have no prior association, and for our surveyors who didn't care one way or the other, we could make a reliable prediction. Yeah, and we found this. So we got it right effectively. 60%, 67% of the time, 2/3 of the time, we got our predicted level matched what the surveyor or the member of the public or whatever said that they would score it. And then for the other third of the time, pretty much all of the other third of the time, we got it only one out. So we said it was good when it was fair, or we said it was whatever. And then there were very, very rare occasions, sort of 1% of the total, less than 2% of the total. We were more than one out. So I think, given the vagaries of how tranquility is always going to vary to some extent, I think that's probably as good as it's going to get. So yeah. Final formula looks like that. Don't bother copying it down. I will send you a PDF if you wanted to know it for any particular reason. As you know from multinomial regression, it comes out with a probability. It is a whole bunch of constants, 35 different constants multiplied by, so for each score you get a probability, and then you pick whichever has got the highest probability, and that is your tranquility score. Those are the actual constants if you want them for any reason. This is patented now. Not so that I can stop anybody from using it. I don't want people to use it, but it's to stop anybody from saying that they invented it. So I've patented it. So yeah, there you go. If you're interested, this is probably more for acousticians than for statisticians, but as you can see, the x-axis on this is the noise level, the overall measured noise level, average noise level, and then you've got the scores. As you can see, excellent, good, fairly tranquil. You've got the whole range of noise levels within there, and even the just tranquil one. You've got a whole range of different noise levels that it could be. And it's only really when you start to get sort of untranquil, as it were, that the actual sound level itself takes over as the principal thing that affects things, which I think is quite an interesting little graph, that one. So just very quickly, I'm probably running out of time now. I shall talk quickly. I'm happy to jump back to things if people want later. So we output to maps. We don't always output to maps, in fact, but I like to output to maps. One, because I love maps, and two, because I think they tell you a really helpful picture. Here, for example, is the main big park in the centre of Ipswich, which is where I live. It's called Christchurch Park. Down here is Christchurch Mansion. Down here at the southern end is the town centre. The bus stop is around here, the big major bus stop. The sound sort of creeps up the hill here. This is uphill. This area here is a children's play area. This is a cut through from the park. There's several cut throughs here, but this is a very busy one, which is affected by lots coming and going. There's a little ice cream stall here, the round duck pond there. There's some tennis courts over this side. And up this end, it's much more leafy and open. You've got a lot of people, there's a sort of walk that goes from here to here, and a lot of people walk their dogs across here, and they get those sort of flingy things with the tennis balls in. They throw the balls down the hill just here. The dogs run down, pick it up, and run back again. So that affects although this is a lovely open green area, it's slightly less tranquil because there's a lot of people there and their dogs having a bit of fun. There's a little natural area that runs across here. And at this end of it, because of it being quite well shielded from other sound, you've got it's actually a little tranquil spot, as is this. So that's the local park on an average May day. This, just out of interest, is what the University of Bradford method shows, which actually is not that dissimilar, but is less. It's slightly more rosy picture because it doesn't take account of the presence of people and their activities. So you can't see the children's play area at all, for example, and the ice cream kiosk and the walking across here. But it kind of gets the same sort of answers. It also thinks the tennis courts are much worse than they are because, although they are a little worse because of the people there, the natural tranquility, the trapped method thinks it's worse because there's a lot more man-made features there. You don't have so much natural features there. So. This is a comparison. Just a couple more maps, just for just illustration, really. This is an area in the Norfolk Broads. This is pleasure boats go up and down here. Each one of them, it probably feels like quite a tranquil place, but they don't half make a noise. They're when you go there in the winter and they're not there, it's beautifully peaceful. It's all reed beds and little warbly birds and things like that. It's absolutely lovely. But as soon as the people come along, it does change. It's not terrible, but it's not as good as it was. And out here is just reed beds and this little bird watching hide here and things like that. This, on the other hand, is this is Shaftesbury Avenue in London. Denmark Street across here and Charing Cross Road down there. I think it's the Seven Dials. You've probably walked along here if you've ever been to the West End. You probably haven't gone down one of these little alleyways here. This is the Phoenix Theatre. Or maybe this one is. No, I think this one's the Phoenix Theatre here. And if you go down here, there's a few taxis that cut through. But other than that, there's this little gardens here called Phoenix Gardens, and it markets itself. It's a community garden, but it says on its website, this is a hidden oasis of tranquility in London West End, and it kind of is. It's pretty good, and because the surrounding area is so untranquil, it feels like a real refuge, and people do go there and sit quietly, considering where it is, it's quite astonishing. Here, as just on the day I was there were some roadworks, which is why that's gone red. But you get the idea anyway. So, finished developing it in, well, I suppose 2018, more or less, 2019, finally. And sort of started writing the book at the end of 2018, updated it as I was going, published it at the end of 2019. Applied for and recently granted my little patent, which I'm very proud of. Got into some branding, got a little website going. There's and even a logo, which you've been seeing. And there's the book. Sold a few dozens of copies, I suppose, something like that. And I really kept count, maybe 40 or something, I guess. Which is probably about the amount I expected to sell it to. Really, it's not aimed at the general public. It's aimed at people who are interested in tranquility and want to assess it. So there you go. Since it's been developed, obviously you've had COVID, got right in the way of everything. But it's been used for the Sizewell power station DCO application. The Sizewell C power station is due to, if it's granted its development consent order, it'll be a 10-year construction project in the east of Suffolk, in the East Coast and Heaths area of outstanding natural beauty, quite close to Minsmere. There'll be 2 new road schemes that will be built to get the construction traffic to and from the site. And the Natural Tranquillity method was used as the main assessment method for tranquility for the amenity and recreation assessment for that project. It's being used at the moment, which I can't say where, but it's in a legal claim against the County Council for building a road and affecting an area of tranquility. Can't say any more than that, but a very large landowner is funding that. It's been used to help design a tranquil garden here in Ipswich, in an area that isn't all that tranquil, but it's used in a beneficial way there to bring in natural sounds and screen out sounds of the surrounding areas to make an area which looks quite tranquil, but also to feel more tranquil. And the only other place being used is quite a really keen guy living in Richmond-on-Thames. Actually just wants to improve the tranquility in his own private garden. Has asked me to help him out on that one. So that was a really quite interesting little job, that. That's it. I think I managed it in 40 minutes, raced through it a bit, perhaps done too quickly, I don't know. Has anybody got any questions?
Yeah. Oh, sharing screen. So thanks a lot for that very interesting presentation. And I mean, I don't know if there are any questions. If there isn't any just yet, then I had I had one myself, if I may. Or maybe a couple actually. So in the beginning, you mentioned about features or rather characters. I think in one of the earlier slides, characters of sounds. So what did you mean by characters, and how would that be quantified?
That's a very good question. And it's a very difficult thing to quantify as well. People talk about anonymous sounds, and anonymous sounds, I mean, what is an anonymous sound? I don't know. It's a sound that you don't notice. And road traffic is probably the most obvious example of that. You might think of some other things like maybe wind in the trees or something like that. It's there, and if you're asked about it, you can immediately hear it, but you don't necessarily recognize that it's there. But sounds with a character, again, it can be a very pleasant character. A song, for example, could be a sound with a character, or any music for that matter. But generally speaking, character is usually a bad thing when you're trying to seek to control noise. Bad noise, noise you don't want, because it's something which attracts one's attention. So a tonal sound, if you trying to sleep in the countryside with the window open and somebody somewhere within 2 miles is reversing a lorry, you'll hear it. You'll hear as the lorry goes backwards, because it attracts your attention. I remember investigating a complaint many years ago where the local residents were complaining about this guy who kept, I think, 400 parakeets. And they said in the morning, at 4 o'clock in the morning in the summer, all we can hear is these parakeets. So I went out and investigated it, and I measured the noise. And the dawn chorus is very noisy. The dawn chorus goes right up. It's sometimes the noisiest thing of the whole day in the countryside. And the parakeets were at the same level exactly as all the other birds. You couldn't distinguish them on the noise trace. You couldn't distinguish parakeet from any other type of bird. But the character of it, as an English country person, you're used to hearing sparrows and whatever the other birds are. I don't know what they're called, blackbirds and things. suddenly a parakeet in amongst that, it wakes you up because what's that noise, because you're not used to it. No doubt if you lived somewhere where parakeets were the norm, you'd be disturbed by the blackbirds. I don't know. It's something which attracts the attention. So things that are tonal, things that are intermittent, things that are, in terms of tranquility, things that raise your alertness. I think things that make you focus. What's that? Is there a dangerous thing? It's fascinating. Just a complete aside on this, that one of my favorite things is birdsong. And I had never thought about it until I started researching for all this. I love birdsong. I feel very comfortable sitting out in the middle of nowhere, listening to birds tweeting away and all that. And it never occurred to me, I never realized the reason why. But the theory is, if you can hear birdsong, bearing in mind we're all just basically slightly evolved cavemen, aren't we? If you can hear birdsong, it means there's no predators nearby. Because as soon as the saber-tooth, whatever it is, comes around the corner to eat you, the birds will all fly away.
Yeah.
So if you're sitting somewhere quietly and all the birds suddenly fly away without even realizing it, you'll go, oh, something's changed. So it's that thing. It's the thing that we like, the soft fascination, the gazing at the clouds or the listening to the bird song or the waterfall or whatever it is. That's the soft fascination, and that's what we don't want to interrupt.
I see. So actually, following up on that, colloquially, we've heard, I think probably all of us have heard the sort of phrase being said about, oh, that's just white noise, right? And so that's something you sort of program your program to ignore, or so we think. Is that so? Is there a frequency characteristic to it, or it's much more complicated than that as well?
Yeah, white noise is actually exactly the same amount of sound energy in all frequencies.
Right. Yeah.
And pink noise is the same thing, but
slope,
adapted a little bit so that it sounds more equal. It's to the human ear. But white noise is just that. White noise is less distracting than most other noise. And in fact, a lot of the time now, for example, vehicle alarms that I mentioned earlier on, they tend to use white noise because although you hear it, it's less distracting. I'm not sure if that makes it safer, but makes it less annoying.
Okay, I see. Very interesting.
Do you?
Yeah.
Sorry.
Yeah, go ahead.
I have a question, Clive. First of all, thank you for such an interesting talk. I really enjoyed it. So I was wondering. I was wondering. So like you mentioned, like people living in urban areas, people living in countryside, rural areas. So they are usually exposed to different level of noise on a day-to-day basis. So do you think this this measure of tranquility should take into account that?
Yes, that's a very, very, very good point. Something which I hadn't really thought about before I did this, and actually I don't think the CPRE had thought about either. Well, maybe they had, but I don't think so. Is that a lot of what your perception of tranquility is affected by what has happened immediately before you come across that space. So if I spend my day at a meeting in London and I have my lunch break and I go to this small, slightly quieter refuge area and sort of sit and eat my lunch and go, whew, like I need to. If I transported that area up and dumped it in the middle of the Finn Valley, which is a beautiful little valley just to the north of where I live, it would be hideous. It would be so noisy I would run away from it. It's exactly the same area. And in actual fact, a lot of the research that led to the CPRE campaign was carried out in rural areas amongst rural people. And a lot of the responses that they gave, I don't think are very representative of the UK population at large. I think they're representative of the people who live in the country, and a lot of it was sort of, what do you think affects tranquility adversely? Being able to see any development was one of the things that was listed. Seeing and hearing cars. Again, I can totally sympathise if you're living in the middle of Yorkshire Moors or somewhere, and people are putting up a new this, that, or the other building, and there's lots of traffic going past. You think, oh, this is terrible. If you go down to Christchurch Park, there's houses and buildings everywhere. There's people everywhere. There's cars everywhere. But you interview people in the park, and they say, oh, it's lovely and peaceful here. Well, it depends which bit of the park, but So yes, it's very, very strongly influenced by what I call neighbourhood tranquility. And I think when, I mean, what I've focused on here is the sort of mathematical method for how to get to a number. But actually what I haven't talked about, and it is in the book, is that is one of 4 steps to assessing tranquility and actually doing a tranquility assessment. The first one is to recce the place, ask people who use it. That's number 1, find out more about it. Number 2 is do the survey and create your map. And then number 3, you then actually moderate those things so that you realize that you're doing a snapshot on a particular day, but it might change from one day to the other. It might change in different weather. It might change in different all sorts of things. And then finally, when you put it all together, you've actually got to say, what does that actually mean for this area?
Mm-hmm.
If it's a countryside area that is, stunningly beautiful and rare and precious, then a change from good or excellent tranquility down to fair tranquility might be totally disastrous. Whereas if you're in a urban environment and you've got somewhere that's fairly tranquil, that probably is even more precious in a way, certainly to more people. So it's really, really interesting. It's a really good question you've asked there, and I've answered it far too long. I apologize. You get the idea.
Thank you. Thank you so much.
Yeah, I wanted to ask if the, in terms of background noise, such as aircraft or trains or roads or something like that, have you looked at the time that it takes people to kind of get used to it? Well, I surprised myself once because when I was exiled to Geneva and I had to go house hunting, the house that I particularly wanted was right under the aircraft flight path into the airport. And I thought, oh dear, is that going to disturb me for a few years? And I took a gamble and thought I might get used to it. And actually the gamble paid off because I did get used to it. So even though I was probably only 3 or 4 kilometers from the airport, it meant that sometimes it felt that as the planes went over, I could just about reach up and touch them because by that stage they were really, really. And the only one that didn't was there was a plane just before midnight going off to South America. And that one made a terrible noise while it was taking. I never got used to that one, but everything else I actually got used to. I'm just. Is there a decay curve you're aware of in people becoming acceptable or accepting it?
There's 2 things to say about this, Jeffrey. One is I think you're talking about noise and disturbance.
Yes.
I'm focusing today on tranquility, and they're not quite the same thing. I'm looking at good noise. You're looking at just noise effects. Noise effects is very important and very interesting. And there has been a lot of studies done on aircraft noise. And although one's annoyance might be reduced and one's perception of disturbance might be reduced over time, probably is reduced over time, the biological effect, the physiological effect that it has on you doesn't change. You are people who live for long periods near to an airport or a noisy thing are at risk of the World Health Organization discusses it. So it changes your changes the quality and the health of your life. It's a bit like living near to long-term pollution or secondhand smoking or things like this. It actually has an adverse effect on your biological system. Either it's your ability to sleep or just on your sort of overall stress hormones and things. Conversely, there have been tests that have been done with people walking into the woods, and they've measured the cortisol, which I think is a stress hormone in people's saliva, and discovered that actually that goes down when you go into the woods. So even though you may not be aware of it, your stress may go down in natural environments. So yeah, you are right. There is a perception that people do get used to an annoying sound, and there's some truth to that. But you need to be a little bit careful looking at a population in that way.
Yes, strangely enough, talking about Geneva, the building I worked in, they did in fact have a white noise generator. And every time I was working, it became obvious they switched it off at 6 p.m. and the environment changed completely, because while I was there during the day, I actually couldn't perceive any of the white noise, but I could certainly perceive the absence of the white noise just by the people talking in offices and so on. Much easier to hear across those.
I have just advised the Samaritans at a local office near here who were having problems with speech privacy, and I advised them to put in a white noise generator to actually raise the threshold in their offices, so that would help. I think it has.
That was my experience. It was actually very effective, but completely unobtrusive.
Not all sound is bad.
No, not quite. No, as you said, bird sound, I love it as well. Yeah,
so can I ask a question? How many of you immediately saw the problem with linear regression when I started talking about this? How many of you immediately thought, no, don't do linear regression? How much of a twit was I?
I didn't think of that.
Me neither.
No, not with what.
Sorry, I was about to ask that question, that why did you take, I mean, because to me, it's a categorical variable, like the way I understand it. And usually for categorical variables, like where you have like, so it's like a category, right? It's like A, B, C, D, like that.
Exactly.
So usually if a variable is like that, we don't calculate regression because
my problem is I did statistics in my third year at university, first time round. That was a long time ago. That was in the early 80s. Honestly, I skipped more lessons than I went to. I didn't. I wish I'd gone to them now, because I didn't really realize all this, and I wasted an awful lot of time until I spoke to someone that knows what they're talking about. So yeah, I did feel stupid when I realized, but it's obvious, really, isn't it? A score of 2 is not half as good as a score of 4. It's just an arbitrary value. It could be red, green, blue, whatever, couldn't it? You know. Yeah.
Yes, but a lot of research is done on that basis. And,
the other thing I found out fascinating about what I did, sorry to interrupt you, but this is really interesting. I was talking to somebody else about something else entirely. It's machine learning. They were talking about machine learning and how the machines had learned to identify a COVID cough. They basically played loads of coughs and told the machine which one had COVID, and the machine could listen to the cough and go, "Oh, that person's got COVID," apparently. And I said, "Oh, how does that work?" And he told me all about it. And basically, they did exactly what I did. The machines, I basically invented machine learning on my own. Well, not really, but basically, the approach that I ended up taking was exactly the same as what they do to teach machines things. So I'm kind of sort of pleased about that in the end. Got there in the end. So. Yeah, honestly, there's a lot more to do on this. I measured 4 things that I came up with off the top of my head, and I've got a reasonably good correlation, but there's probably about another 20 things which might have an effect, which you could measure much more accurately, especially the more modern. I mean, the meters that are available now are better than the meters that were available 5 years ago when I started this research. And I think if I was doing it again now with the blank sheet of paper, I would measure an awful lot more things, and I might very well have 27 variables, and I wouldn't worry about how am I going to determine these, because I just let the machine do it. So yeah, I don't know. I think in future this method, this is just a starting point really. In the future, this method will be taken over by people who study what's called soundscapes, and they're not just looking at tranquility; they're looking at what sound is appropriate for a situation. So, for example, if you go into a coffee shop, you don't want tranquility. You want a lively, intellectual place to go to, and so on and so on and so on. You don't necessarily always want tranquility, or always want it to be loud, for that matter. There's different things that suitable, and they're trying to define parameters that they can use to describe. And there's millions. There's years of work to go into that. At some point, somebody who knows about soundscapes, somebody young, not me, will pick this up, and they'll do a better job than I've done. But hopefully, they'll do it in a similar sort of way. So, but it's good, isn't it?
I mean, artificial intelligence will have an impact, but you know, the standard joke about building expert systems is that the greatest problem before building an expert system is finding the experts. It's not the programmers, it's the experts that you need.
In this case, of course, we're all experts because we all know what we think is tranquil.
Yes. But I do like the correlations that you've come up with, because there you're able to show really that people, although it's a very individual, subjective thing, or it appears to be, there is a lot of if you like, crowd wisdom about this, about the different people thinking along the same lines about what's a tranquil environment and what isn't. I find that fascinating.
Yeah, I was actually quite taken by the fact that the people seem to be very good tranquility detectors, and very consistent, and repeatable is the word you used, which is that's extraordinary.
Yeah, that graph that we've got there is really, it's our surveyors. If you were to take that graph and ask random people that you met in places, everybody would overscore everything, almost exclusively.
Yes.
Because I mean, as a classic example, I think it made it into the book. I think it made the cut. My wife was out helping me survey once, and she would go around talking to people, because she's much better at approaching people than I am. She's young and pretty, and I'm old. And so she walks out to people and says, "Oh, hello, can I ask you a question?" She spoke to this woman who was in a wheelchair. And she was in Christchurch Park, sitting outside the toilets, not the most salubrious place in the park. And she said, "So can you tell me, out of a score of what?" And this woman, she could not speak highly enough of the park, and the place that she was in was grotty. It was in terms of that park, it was probably one of the worst places. She said, "Oh, fantastic!" She's giving it a score of, it was paradise on earth. Then she asked her a few questions. "How often do you come here?" "Every day." "Oh, so really? Tell me more about that." And it's a little bit of an unstructured interview, to be honest. Anyway, it turns out this woman was basically there every day. Her carer picks her up and takes her to the park for an hour. And that's the only time she ever gets out of the house. And then she goes back again. And so for her, this park, on any score at all of goodness, it gets 10 out of 10. And when we're all a bit like that.
Yes.
We all, I go to my Finn Valley, which is just up there. Finn Valley's not that amazing. It's got a stream which you can almost jump across. It's so small. It's not really even a valley. It's just a sort of slight indentation. But for me, it's lovely, because I go out there, and that's where I go to get my peace and quiet when I'm living in the town of Ipswich. So we all have our biases, and it's very important that when we've got a tool, and this is kind of one reason why the tool is so important, is if you've got a planning inspector who's going out making a decision, should this development go ahead or should this development not go ahead? If that planning inspector's got their own bias, which we can't help it, we all have some bias.
Yes.
The planning inspector might be a very urban sort of bloke, and he's thinking, "Well, this is amazing, this place," or it might be someone who's a very rural person thinking, "Well, there's nothing that special about this." He's got his own, so it's really important that we do have an independent yardstick, so that people who are making decisions actually say, "Well, I feel it's important because it's my special place," but actually ranked against the other places that are out there, it isn't as special as I thought, or it is particularly special. And therefore the decision, the idea behind this method is not that it helps people stop development or that it helps people promote development. It's supposed to be a neutral tool that allows people to make decisions based on science rather than on feeling. Which I can't believe I'm saying that, because I kind of, science isn't everything, is it? No. You know.
Cool. So I'm not sure if there are any other questions, but so if that's the case, maybe Jeffrey, we can thank Clive and end the session.
Yes, I think, thank you very much indeed, Clive, for doing that. I thought it was absolutely fascinating, and it's very nice to see the statistical underpinning of the work that you're doing, because it's a real application. It's a wonderful application of the statistical approaches to everything, and I think that's what everybody here appreciates, because that's what we're really focused on. And I think you've got some very remarkable results, and keep going, because I think you're right. I think it's going to evolve, and hopefully instrumentation will evolve as well, and that will make it more interesting for you in the future, I think, to increase the complexity of the models. And if artificial intelligence comes along to give a bit of support, but as I say, it's finding the experts is the big problem. And of course, computers, normal digital computers, they're absolutely stupid, but they're just very fast at being stupid. And And artificial intelligence and heuristic programming, ultimately everything still must be converted to a series of algorithms in order for a computer to be able to work. So I'm totally fascinated with what you've been doing on tranquility. So
well, thank you for your support, Jeffrey. It's been helpful.
So thank you for your contribution tonight. I think that's been really wonderful.
You're welcome. If anybody would like a copy of the slides, I will send a PDF to, who should I send it to? Is it you, Jeffrey, or?
Yes, you can send it to me.
Yeah.
That's fine. Yes. Yeah.
But please
they can
feel
acquire
free to do as you wish with it. The idea here is, I have copyrighted the book, but it's only so that someone doesn't steal it. So
no, that's absolutely right. Yeah. Yes. Yeah.
Okay.
You don't want somebody to actually take the book and the worst case scenario is use bits of it and actually change what's in the book. So your use of a patent, I thought, was particularly interesting from that perspective as well.
Yeah, if you want to steal it, if you just steal it in France or China or America or something.
Yeah, well, actually, if you wanted
England,
to,
I haven't got the money to protect it anywhere else. Anyway, I shall clear off and leave you to the rest of your important bit of meeting.
Okay. No, I think that's probably it. But thank you very much, Clive.
Nice to meet you all.
Really appreciate it.
Very nice to meet you. Cheers.